Welcome to today's webinar. The topic today is masonry design using finite element method in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, the webinars, customer projects, etc. I will be the moderator today and I will answer your questions during the webinar together with Frank Faustich, but my two colleagues can introduce themselves.
Hello, my name is Ulrich Lex. I'm responsible for quality management of RFEM together with development of the add-on glass and the add-on masonry. And today I will present the webinar.
Hello, my name is Frank Faustich. I'm responsible for the quality management of our software.
Yeah, and you will help me with answering the questions, of course, but I said it at the beginning. Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can enter a short question here and we will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over the screen to Ulrich.
Okay, thank you very much, Andreas, for your introduction.
We can see your RFEM screen at the moment.
Yeah, just a moment. No. So today's webinar is about masonry. My presentation is created into three parts. The first part, the theory or basics of the used material model. The second part is the modeling of masonry structures, especially how to use it in RFEM 6. And the third one, the evaluation of the results. Add-on masonry design. The add-on masonry design was developed completely new in RFEM 6. It was developed in a research project in cooperation with partners from science and business. The research project was called Digitizing the Design of Masonry Structures. The main project partners were the Institute of Structural Design at Graz University Technology, the BRIC Initiative or the Association of Austrian Brickworks, the Ziviltechniker Büro Dr. Pech in Austria, the Werkram engineers in Vienna, and the company Wienerberger. The aim of the development was to find a method to make the masonry material more attractive and effective in use, and to create the possibility of being able to use the material in a modern software environment. Topics like BIM, building information modeling, and there's the exchange of models or systems between an architect and special planners, or the creation of capacity curves for the whole building to estimate earthquake resistance played an important role there. Now it is also possible to compute, I will call it mixed structures, for example for concrete and masonry in one 3D model. After detailed investigation of various published material models, we decided to use an approach according to Lourenço. This theory includes 3 yield surfaces, called Rankine-Hill surfaces, with which the material is described. There would be many different or more different approaches available. For example, with more yield surfaces, that would mean that the material behavior would be described in much more detail, but there would be also disadvantages in implementation or in stability of the calculation. The comparative calculations showed us that the results are very good with our chosen material model. How do it works? When the material is entered, a stress-strain curve is generated from it. In the calculation, the solver will use this stress-strain curve to solve the system. Due to the orthotropic behavior, a separate curve is generated for each direction. The material parameters. The material masonry is not an easy one. It's a composition between stones and mortar, or even glue. The difficult now is to describe this masonry material in such a way that realistic load-bearing behavior is reflected. We did a lot of test evaluations and comparative calculations where we optimized the curves in such a way that the load-bearing behavior, what is specified in EC6, is reflected to our computation. As a result, if the program computes successfully, design close to the Eurocode is given. The program does not reflect a design ratio, because this is not possible for a nonlinear calculation, but the check is fulfilled when the calculation is successfully completed. One of the next steps is the slab wall connection. A special topic in masonry constructions is the slab wall connection. Due to the special geometry and behavior of masonry, the connection point also requires special attention. As you all know, lies the slab, the concrete slab for example, not complete on the masonry wall. There is mostly an offset, and that's the reason why the material model itself cannot react completely right at this point. In principle, the corresponding moments are already entered into the system through the concrete slab. For example, with a bigger slab span, there is a bigger moment in the wall. If the moment cannot be transferred by the wall, then the material model responds. Our FE elements are internally divided into 9 layers above the thickness. If the allowable force is exceeded in one layer, then it fails and the wall thickness decreases, and the connection will react with lower stiffness. But the problem is the offset. That's why we developed an interaction equations where the maximum possible moment in condition to the normal force is considered. This topic can now be considered with a line hinge in RFEM 6. That's now all for theory, and I will switch to the program to continue with modeling. There will be also an explanation report to the research project available on our website as soon as possible. Actually, the report is on last revision, And when this will be finished, then we will publish it on our website. So, and now to the program. I prepared a simple, easy structure to show you all the things you needed to compute a system with masonry. For the first time, the material or the add-on masonry can be activated on the base data. Here you can switch to the add-ons and activate the masonry design. On the third register, you can choose the standard. Actually, there is only the Austrian standard implemented, but we are continuing to implement more and more standards. So you can continue this. Okay, then we can create a new material. If I activated the masonry design, then I have the possibility to choose a material type masonry. And after that, I can choose one material model. There are two different material models for masonry. The isotropic linear elastic is our standard material model. The isotropic masonry is our, I will call it old material model from RFEM 5. Here you can limit the stresses in X and Y direction, but you have no influence of the shear or the orthotropic behavior. This orthotropic masonry plastic surface is our new developed one what we will choose. If you do this, you get a new register for classifications and material. Here you can enter the parameters of your used stone mortar combination. If I go to the website, maybe from Wienerberger, unfortunately this is in German, but I had no English one. You can find the dimensions of a stone. You can find the compressive strength, the stone group, and you can find which mortar can be used. If you know these things, you can insert it here. We want to choose in stone with grouping 2, together with thin layered mortar, with dimensions 250, 249, 380, compressive strengths 5. The horizontal compressive strength is mostly not given, but it's about 10%. And 1. Here you have the possibility to enter a partial factor on material side. It's in our case for thin layered mortar the 2. And the last part, you can activate that the head joints are filled. Mostly you need it if you use maybe a lintel above an opening. So if you entered all these things, then automatically the parameters for our used material model are calculated. You see in the upper part the E module, the difference in Y and X direction. Therefore it is really important to check the local directions, that the Y direction is in this direction where the load is acting. Then you have the compressive strengths and the tensile strengths. And in the part down, there are some parameters for the material model. This is one option. The second option is to use our material library. You can choose it. You can set material type masonry, and there are a lot of stone mortar combinations. We are developing, and we will fill this database with a lot of more stone mortar combinations. Here I can choose again my porotherm with thin layered mortar. On the left side down I have an info button where I can see which parameters are in the database. With double click can I choose these parameters. The parameters are filled automatically. So the same I want to do for a second stone type for my inner walls. And I will continue with OK. So if I have defined my material, I can define the thickness as it is common in RFEM 6. I create a new thickness, choose my material and enter the thickness of the wall. Please be careful. The thickness of the stones is not automatically the thickness of the wall, because it's possible for small format stones that it is different. That's why it's not connected automatically. And I will create a second one for my inner walls and continue with OK. So what I did before too, I created some object selections, one for the outer wall and one for the inner wall. This is easy possible if I mark something, or if I mark the wanted objects, click on the right and create a new object selection. Now I will assign my thickness for the outer walls and click OK. Here I will check also my local axis so that my Y direction is in the load acting direction. And what I did too is to orientate the Z direction inside the building. That is not a must, but it helps me later to read the results correctly. Okay, as a second part I will assign some material for my inner walls. Okay. Now I have created the masonry structure. What have I do as next? I have a lot of openings in the building. Because of the material, it is important to take a look at these openings. The material has a very low tensile strength. So it could be that this part over the upper part from the openings maybe how should I call it? It falls out. So it's necessary to assign there a member. This will I do as a next step. I create a new member. Maybe with 300 and only 55 millimeters in the height. And choose all. Lines from opening. Okay, for the bigger openings, I will create a second member. Maybe with 300 and high 200. Okay. If the openings are not too big, it's okay that we connect the member with the surface on one FE node. If the opening is bigger, then it's maybe necessary that you bring your member in the surface, maybe 10 centimeters, like it is in reality, so that not all the load have to acting on one FE node. But in this case, it is okay as it is. Okay, as a next part, I have to look for the wall slab connection. The wall slab connection, as I said, can be assigned as a line hinge. That's why I create a new line hinge. If you are in the dialog line hinges, you see you have the option slab wall connection. If you check it on, you will see that this is not a real hinge. It's only a placeholder for the hinges in the masonry wall. This placeholder or this hinge is located on the slab and there on all lines, on all outer lines. The same I will do for the slab above and choose all outer lines. Okay. Then I can switch to the slab wall connection register and to enter an offset. This offset describes how big or how long it is. A second option is to enter a block width. When I entered here in value, then you can see what is the meaning of it. It's an additional stone on the outside of the wall. But in our case, I will not do it. Okay, if I have now described the geometry of my connection, I can generate the new line hinges. If I click on this button, I generate 2 new line hinges. The amount of these hinges is not necessary because it is depending how the location of the local z-axis of the surface and the orientation of the line is. These hinges are in a different color. That means they are not able to edit. because they are connected to this geometry. Of course, you can disconnect it, but then you cannot. You have not the intelligence if you change something on the first one. There are generated two-line hinges, but you will see that the hinges are the same, only it's located in a different quadrant. So if I click OK, then we can see that we generated two new hinges. This one is our placeholder, and here on the masonry wall we have our hinge for the connection. So here a short I will show you some details. If you have two surfaces on the slab, you saw it already. It's no problem. You can easily generate the hinges for on the masonry wall. It doesn't matter if the thickness of the wall is the same or different. There will be generated the correct hinges. In cases that you have different materials, you can also use this slab wall connection. Now if you generate it, you get a warning message of an invalid material. But if you click OK, you will see the invalid material is a concrete material, and this is okay because there should no hinge be generated. And on the masonry wall, the correct hinge is generated. You have to be a little bit carefully. In such cases, it is modeled in this way that here are double lines. This is not good. You can find it also with tools, model check, overlapping lines. But this is not good for the modeling, because if you generate here the slab wall hinge, you see that only on one wall the hinge is generated. So it's even better if you connect, or if you model it in this way, that you have only one line, and then the generation is okay. So now back to our house. Okay, the line hinges are generated. The next step I can do is to generate the FE mesh. The FE mesh settings, well, it's recommended to use a FE mesh from 25 or 20 centimeters for a masonry wall. It's because of the material data. There we can say are the best results. For concrete, of course, you can use a bigger FE elements, and for the masonry, of course, if you need it, you can also use smaller elements, but I would not use bigger elements. Because of the nonlinear material, it is also important to generate, I would say, a nice mesh or a regular mesh. because otherwise you will get some singularities what are not a problem of the system, what are then only a problem of the mesh. So in my case, the mesh is looks very good. So I can continue with the next step. The next step would be the loading. I have prepared simply 3 load cases. What I want to explain is a little bit the settings. So the static analyze settings, you have the option to choose an analyze type. It's possible to compute the masonry with geometric linear or large deformation analyze type. For, I would say, easy systems, it's enough to use the geometric linear system. If there is a big bending, or if you want to use or to come on the borders of the material behavior, it's necessary to use the large deformation. For the nonlinear material, it's also necessary to use a number of load increments that you not only compute it with one load increment. It's because of that the material or the FE element has the chance to load it in a slow way. The FE elements. So you have to choose, maybe a good number would be 5 or 10. Here you can save the results for all increments. Then you can see afterwards what is happening in calculation. Okay. If you have done these settings, then you can compute. Then you can compute the system. I prepared it for you and want to show you the results. For the results, you have all results available as they are in RFEM. The first thing is the overview of the static analyze. Here you can see that the computation was successfully without any error. So the masonry itself is okay. It's always necessary to check the deformations. There you can find maybe input errors or something else. Especially for the masonry material, you can check then the stresses, but the stresses cannot be higher as they are defined in the material model. So it's maybe more interesting to take a look on the strains. Especially for this system now, all the specialists of masonry will know it. It is the slab. It's the first slab. And here we will take a look on the strains. If you take a look at this edge, then you will see that the strains on the outside in Y direction are tensile strains. That means maybe there is a crack in the masonry. in the beginning I checked the plus and minus side, and when we remember, the plus side is inside the building and the minus side is outside. Now I can take a look on the inside strains and see there is also a tensile strain. That means my crack will be above the whole thickness. This can be avoided if you add a member or an attica on the slab. But with these things you can take a look and to see if there is any crack in the masonry. One more thing is also the criteria. Here you can see the nonlinearity rate of the material. The red one or the red marked elements are not overloaded. It is saying that this one what are blue are on the linear elastic part of the material model, and the red ones are in the plastic part. Here you get a feeling what happens in the building and where the problems maybe are. These all things you can document. You can document in the printout report to document all the results. So, and as a last part, I have prepared some more example. It's our small building, and there I want to create a capacity curve, maybe to get a feeling for the resistance of an earthquake. So how can I do it? For this I have to activate at first the add-on stability, structure stability. The other things are the same as we did it before, and I created a new load case. I have my normal vertical load cases, and I created one load case for horizontal loads. This horizontal load case is only a unit load, and I will increase this horizontal load until the system is in collapse. How can I do this? I can create two load combinations. One load combination with my vertical loads, and the second combination with an additional horizontal load. Now I can say, okay, my vertical loads are an initial state. That means that I will not increase these loads. After that, I can activate structure stability add-on and say, okay, I want to increase my loading with incremental method. Activate this. Here you have to save the results and you can assign to this combination 20. In the static analyzing settings, you have the possibility to activate calculation diagrams. For this calculation diagrams, you have the option to choose much things you want to see. In our case, I want to see the sum of support forces in x direction in correlation with the node deformation in x. You have to choose one node. And with these settings, you can start the calculation. So if you finish the calculation, you can see that I can increase my horizontal load about 60 times, and after that my system will falling down. In the criteria you can see now also the shear forces what are in the system. And as a last part, you can take a look on the capacity curve. You can take a look on this calculation diagram, and this is the capacity curve for this building. Here you can see the linear elastic part on the beginning, and if you increase the loading more and more, you will come in the plastic part. The loading will not be much higher, but the deformation will increasing. And this curve you can use maybe for some other calculations. Okay. Now I'm on the end of my presentation. I would say thank you for listening and go back to Andreas.
Okay, thank you, Oli, for this nice presentation. Just for information, we recorded this webinar, and before I will show you where you can find the recording and the used models to download, I would like to introduce you some new or free tools that we provide. Just a moment, I take over the screen again. So, our free online services, e.g. the GeoZone tool for snow, wind and seismic loads. Then the cross-section properties, it's a large database with cross-sections, and you can define your own parameterized cross-sections. Then the FAQs and knowledge database, the models to download, also with the webinar models. Then on our YouTube channel you will find the webinars and other useful videos, tutorial videos, etc. Our web shop is with prices, and you can download the trial licenses of RFEM, RSTAB, RWind and so on. RFEM and RSTAB contain the those are full versions with all add-ons. Maybe I will show you the home page. Okay, you will find the free full trial version here. RFEM, RSTAB, RWind, RSection, etc. And you can use the RFEM trial, for example, for 90 days, also with the add-on masonry design. Okay, if you want to find the recording under news and events and webinars, you will find today's webinar here. And in the next days you will find the recording here. The presentation slides are already there, and also the two used models. Okay, that's also all from my side. I say thank you for your attention. Thanks to Ulrich Lex for the nice presentation. Thanks to Frank Faustich for answering the questions. I wish all a nice rest of the day. Okay, and yeah, bye-bye.